So operations on sets. Operations on sets. Now the first thing we are talking about is intersection. Now intersection simply means that a property belonging to two sides.
Okay.
So this because high school invited the school athletic team for a dinner at his residence. It's made up of 8 sprinters and 5 headless. He realized that there were 10 athletes in his residence. He checked and found that all the athletes were present. But then if you have 8 plus 5, it should be greater than 10. So here, the analogy that this is giving us is that how can there be a football team of 10 players, or let's say 10 athletes? Now, in this case, the number of the footballers or the athletes is called a universal set. So now your universal set is 10. When you add up both sprinters and headless, it is the case where 8 people, sprinters, and then 5 are headless. When you add 8 and 5, you have 13. But then the team is made up of 10 people. So it means that there are some people in the team, they are sprinters and also headless. So these people, when you are counting sprinters, they are present. When you are counting headless, they are present. So the solution is much easier using a Venn that I use S and H to denote the sets of students who are sprinters and headless respectively. So this is what we have on the Venn diagram. So the information is illustrated present at the dinner. And it follows that 3 members of the team who are sprinted also be headless. The set of elements which are common to both S and N is called the intersection of S and N. So for intersection, they are a group of people that belong to side and at the same time belongs to side B. Now, in 2 set problems, this group of people called the intersection are always located in the middle of the Venn diagram. In the middle of the Venn diagram. So this is it. I am writing on the other screen. So I take this as a set. I take that as a set. Now I'm going to write 1, 2, 3, 4, 5, 6, 7, and 8. The number of athletes that are sprinters, 8. And then I also have a number of them that are headless. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 4, 5, 6. Now I can easily tell from this, there are some numbers that I have, they appear in both S and H. Both S and H. If you need 4, you get it here. If you need 5, you get it here. If you need 6, you get it here. In the same way, if you need 4, you have it here. So I can boldly say that since 4, 5, and 6 appear on both sides, that is our intersection. Now I can combine these diagrams. So this is what I have. Now I have my U here, which represents the universal set. Now in the universal set, you don't tell whether this belongs to that or this belongs to that. Once they all belong in the set, then it is part of the universal set. There are some people who even belong to a team, but they don't play any role. So let's say you are in a team. People are sprinters, others are headless. There are still people in the team. They are neither nor headless, but still they are part of the team. So they are part of the intersection set. Good. You can hear me clearly. Hello? Hello?
Yes, sir.
Okay. Good. Now I have headless. So now I know that I have 1, 2, 7, and 8. And then 4, 5, and 9, and 10. So this is what it means. Now, 1, 2, 3, 4, 5, 6, 7, 8. They all belong to S. And 4, 5, 6, 9, 10. They all belong to H. And then 4, 5, 6 also belongs to both sides. Now, if there were members of the team that are neither sprinters nor headless, they will be located outside these circles, but universal set. So here, they are called complement. Complement. So this is where the complements belong. Complement. Good. The intersection of two sets, A and B, is defined as the set of all elements that belong to both A and B. So the operation, so this operation is like something like this. It's used to define the intersection between two sets. Intersection of A and B is written as A intersection B. Good. For example, if we have a set of A, which is 1, 2, 3, 4, 5, and 8, and then we have a set of B, 2, 4, 6, 8, and 10, then A intersection B is equal to 2, 4, and 8. Why? Because 2 belongs to both A and B, 4 belongs to both A and B, and 8 belongs to both A and B. Very, very simple. Very, 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 very simple. Good. Now let's continue. Now union set. Union. So the union of two sets, A and B, is defined as the set of all elements that belong to either A or B or both. or both. So it means that now when I want to illustrate with the sprinters and the headers, now it means that the union is going to entail them added together. But one thing you have to remember is that now in a union set, numbers don't repeat. For example, and another two again belonging to set B, you pick only one. Even if they appear three, only one. That is the rule. So you can't say two has appeared here. For example, let me use this example. Let me use this example. So this is it. A, set A equal to 1, 2, 3, 4, 5, and 8. And then set B equal to 2, 4, 6, and 10. Now, when you are to write the A union B, it means that you are just combining these numbers. That appears twice. You are supposed to select it only one. So here I have one here. One is not here, but it is union. So one will come. Now I have two here and I have two here. I am going to select one of them. So I have three here. I don't have three here. I'll still write it because it's part of the union. Four here, I pick one. 5 here, it's not here, but then I'll pick. Now from here, I have 6. And then 8 is here, and then 8 is here. And then the last one is going to be 10. So you realize that every number I find in the union set can be found in or both of them. That is how the union set actually works. Good. So now let's move on to complement and the rest. So good. Now example 1.10. If P and Q are the subsets of a universal set U, then shade the sets. So let's go and then see. Explanations to them. So I have P intersection into brackets P union K. P intersection into brackets P union K. Good. So I have my Venn diagram. Good. P intersection into brackets P union Q. So this is it. Always solve the one in the bracket first. The one in the bracket first. Good. So you have P union Q. So P union Q. Your universal set is here. This circle is P, and this circle is Q. Good. So P union Q means that all elements that involve P and Q. All elements that involve P and Q. So this is what I have. And use a rule for you to get it better. So I have this. So this is P union Q. Anything that involves P and Q. Good. Now we have P union Q. Good. Now let's find P. So this is P. P is equal to P and Q. Good. So this is P. Anything that involves P. Now, when you look here, I have added the universal the intersection because there are elements in the P. But if you look at here is only Q. There's no entity of P in it. This is the bodies. The bodies are here. So that is P. And that is P union Q. Now you come to the main question. P intersection into bracket. Now we know that intersection is something that belongs to point A and at the same time belonging. Look at these diagrams. It is easy for you to identify that it is only this portion that belongs to this part and also belongs to this part. So when you draw them like this, it becomes very, very easy for you to understand. Because this part is P and this part is P union Q. Now you're looking for the intersection. So this whole part and this whole part, which part belongs to both this and that part? You can clearly tell that it is the same region as P. That is the reason why they gave you P intersection into bracket P union Q to be equal to as P. So that is P, that is Q. Now P intersection P union Q is this place. So in other words, you can say that P intersection P union Q is equal to P. When you write just the letters like this, it becomes very confusing for you to understand. But when you draw them out, because it is very easy, you know P union Q, anything that involves the two, you know only this one. Now P intersection Q, this is it. So you can boldly tell that P intersection into bracket P union Q is equal to P. See, some of these questions appear in the WASI just to trick you. It is not anything difficult once you are able to draw them. It is not anything difficult. So let's move on to the B, and then I'll give you some examples to draw out for me. The drawing is not difficult at all when you understand the sets. So the second one is P intersection Q complement. So this is it. So P intersection Q complement. Now, in the first place, we have to know K complement. You have to know K complement. Now, a complement means if I have a universal set U, which is equal to the set S 1, 2, 3, 4, 5, and 6. A, set A, which is equal to the members 2, 3, and 5. And then I have another set B, which is equal to the members 1, 4, and 6. Good. Now, anytime you hear complement, the first thing that should come into your mind is the universal set. Because every complement has to do with the universal set, because it relates about to the universal set. So here, if I decide to find complement, now A complement means that look at the elements of A, the numbers that A has, go into the universal set and pick those numbers out. When you pick those numbers out, the rest that is left inside the universal set is the complement. So complement hasn't of that set. No. Complement means that go and remove the members of that set out. The rest that is left in the universal set is the complement. So now if I say find, now A complement means that I need to know the elements of A. So I know that A has 2, 3, and 5. Then I go to the universal set. I pick 2 out. I pick 3 out. I pick 5 out. Now, what is left in the universal set? 1, 4, and 6. So A complement is equal to 1, 4, 6. This is A complement. Good. This is A complement. So now let's move on to our initial question. So P intersection Q complement. P intersection.
Sir,
So now we need to, yes, okay.
please, so can you say that if you have A and B, can you say that A complement is equal to B?
Yeah, A complement is equal to B.
Okay.
Yes, based on the elements I gave you. So A complement is equal to B. Highly examinable WASI question. So they can just bring it to confuse you. So A complement is equal to B. B, A is equal to B complement. C, or A complement is equal to B complement. C, A is equal to B. And then maybe D. They can say B complement. So when they bring it like this, then you are sure of which one you are selecting. You are sure of which you are selecting. Good.
No, sir.
Okay. So now P. So this is it. My Venn diagram. Good. Now I have 2 sets. My universal set is always here. Now this is P and this is Q. Now the first one is P. So let me shade P out. So this is my P. Good. Anything that involves the P. This is my P. Good. Now the next thing I need to find is Q complement. Q complement. So this is Q complement. universal set is here. I have my P. I have my Q. Now it means that if I have Q, now Q complement, just as I used the A and B to explain here. Q pick any area that is involved with Q or that has something to do with Q out. After the rest that is left is the Q complement. So when you look at this diagram, what can you say Q complement is? Where should I shade? Where do you think I should shade? When you pick anything that involves Q out, then can you hear me? Hello? 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 Yeah, can you hear me? Good. So now, when I pick, I can boldly say that Q complement is this part. Yes. Because when I pick anything that is involved with Q, this is what is left. So this is Q complement. That is Q complement. Now you come to the main question. P intersection Q complement. It means that give us a portion that belongs to P and also belongs to Q complement. Now when you look at these two pictures, you can tell that only this portion here and also belongs to P complement. So that is it. So I have P intersection Q complement to be this. Okay, so I have P, I have Q, your universal set is here. So this place. P intersection Q complement. This place. So you can say that here, P intersection Q complement is equal to Q complement. Because that is Q complement. That is P. That is K complement. P intersection K complement is this part. So you can easily tell that P intersection K complement is equal to K complement. Look and look at P intersection K complement. They are the same. So P intersection K complement is equal to K complement. Very, very easy. Good. Now let's continue.
So please, can I see the question?
Okay. Example 1.1.
Thank you.
Okay. You're welcome. How is it going? So here they have given you the intersection. Do you see that?
Yes, sir.
And then they have given you the complement. And then
Yes.
your university is 130.
Yes.
Good. But they didn't give you both comics only and novel only. Do you see that?
Yes, sir.
Mm-hmm. So you can choose to let a number represent a different number for comics only, and then a different number for novel only. And then per the word problem here, twice as many students read comics as read novels. You can relate that one and get two separate equations. So this is something that involves simultaneous equations. I think we did it in JHS, or I don't know. Do you still remember?
Yes, sir.
Okay. So one of the equations will be coming from the twice as many students read comics as read novels. That is one. And the other equation, you know that the comics only plus 30 plus novel only plus 10 should be equal to 130, which is the universal set. You have two separate equations. Try them and give me the answer for y and x.
Yeah, please, I don't understand.
Sorry. Let me give you. This is a highly examinable question. So I think it's a past question. Good. So a survey. Let me mirror this one for you. So a survey of reading habits, 130 students. So your universal set is 130. Your universal set is 130. Give me 1 minute. So U is equal to 130, like you have there. Now, 30 read both comics and novels. So your intersection here is given. That is the 30 there. I hope you can see the chart.
Yes, sir. Yes, sir.
Good. Now, 10 read neither comics nor novels. So that is the 10 down there. But it is still inside the universal set. And twice as many students read comics as read novels. So it means that comics is equal to 2 times novel. I don't know if you understand that statement over there. Twice as many students read comics, read novels. So it means that the number of students that read comics is 2 times the novel. Now, how many students read novels? How many read comics? How many read only comics? Now, the solution, your universal is 130. Good. Now, comics is not given. And novel is also not given. But you have your complement in the intersection. So here, the only option is to represent comics only and novel only by different variables. So let X be equal to the number of students who read comics only, and let Y the number of students who read novels only. Once you have this only and that only replaced, your Venn diagram is full. Should there be anything anywhere again? No. The Venn diagram is full. There's no spot or space anywhere. Now you come to how you can be able to solve this, because you have 2 different variables. It is only by simultaneous equation. And you also know that X plus 30 plus Y plus 10 should be equal to 130. This is the first equation, equation 1. And then when you come to the question, remember that they said twice as many students read comics, read novels. So here, students that read comics is equal to X plus 30. And students that read novels is equal to 30 plus Y. So if now you know the number of students that read comics and the number of students that read novels, then it means that you're going to have x plus 30 is equal to 2 into bracket 30 plus y. Do you get how the equations are coming about?
Yes, sir.
So I'm going to scroll from there. With the information you have now, try and find the values of x and y. And let me see.
Okay, sir. Thank you.
Okay. Welcome. So the only thing you'll be doing is the grouping like terms and then crossing over the equal to sign. And then you arrange them into proper simultaneous equation. Now you have substitution and elimination. You can use any of them. So find the values of x and y. Now, when you're able to find the values of x and y and you put them inside, any question they ask you about the Venn diagram, you can answer it. It's very, very easy. That's the first one.
Sir,
So how is it?
is I go x to be 70 and y to be 20.
20.
Yes.
So good. So x is 70 and y is 20. Good. Very, very tricky question. Highly examinable. So now the number of students who read novels. Yes. What did you get?
Number of students who read novels.
Hmm.
It will be 30 plus y.
And y is what?
Y is 20, so that is 50 students.
Good. Now the number of students that read comics.
It will be 30 plus x, and x equals 70. So that's equal to 100 students.
Good. 100 students read. And then you have comics only to be 70.
Yes.
You get?
Yes, sir.
It's a very highly examinable set question. Now, when they give you some of these questions, you have to think why. Or what is simultaneous equation doing in sets? So mathematics cuts across a lot of places. So everything you learn is very important. Now, 3 set problems. 3 sets problems. We are almost heading to 1 hour 30 minutes. We'll be done in no time. At least by 2 hours we'll be done. Like it's left with 30 minutes.
Okay.
So I think we finish with a 3 set problem. So these are questions that you're able to shade. These are questions that you should be able to shade. So now I'll just go through these things. The application is just like the 2 sets. For example, A intersection C. Anything that involves A and C. So you have it there. B intersection C. You have it here. A intersection B intersection C. So in a 3 set problem, the intersection is the middle part. That is what it means. You see this one too, it has intersection and union. Union, intersection, union. You see the complement to it here. A complement, intersection B union C. So this one you have to be able to solve them separately. Then you add. So you know A intersection B. After you've been able to identify A intersection B, then you union the whole of C to make it very easy for you to do. These ones, they still come in the WASI. So let's look at something like this one. So B, this is A union C intersection B union C. So A union C is shaded vertically. That is A union C. And then B union C is shaded horizontally. So after you do that is why I was looking for a rule. If I had gotten the rule, I would do vertical representations and horizontal representations. After you are done, the place you are actually looking for will be a box. You see, look at the diagram B. Now A is vertical, B is horizontal. You see, the place you're actually looking for is a combination of the horizontal and vertical, which makes it very, very easy. So all these ones, I think they are in the A plus and the Aquila. Try your best to go through them. They are not difficult at all. Look at this one. P intersection Q, union R intersection Q, or Q intersection P union R. All these ones, they are just there to confuse you. If you're able to break them down one after the other, it will lead you to which one to shape, which is very, very easy. Very, very easy. So now let's see. I have our first 3 set problem. So I think you have some shadings to do. So in a certain class, each student offers at least one of the following subjects. Whenever you hear something like this in a set question, it is just a confirmation. It is telling you that there is no complement in the question. So you shouldn't expect anything outside the 3 sets. So they will just bring it inside. You might think it is something to confuse you. No. So in a certain class, each student offers at least one subject. It is just to confirm that all the students are doing one subject. It is not that it's anything that should confuse you. Good. So now that you have the confirmation that there is no complement, you can move on. So the subjects are accounting, business management, and commerce. So represent by shading on a Venn diagram the region that represents the number of students who offer the following. So 1, all 3 subjects. 2, accounting and BM only. 3, accounting and BM. So there's a difference between the only and the general one. Good. Now, the 4th one is commerce only. The 5th one is accounting or BM only. And the 6th one, accounting or BM. Represent by shading. And let me see.